in both. Let's do a quick count. 15 and 15. So when you look at the molarity, they are the same. Number of moles of the substance is going to be the same. When you look at the weight, it's going to be different. Okay. So a lot of solutions, when they use the molar quantities depending on the needs and context and the situation. So you need to understand. That's why they have given a nice illustration to differentiate the weight and the molarity. Then moving on, electrolyte concentrations at the body level, we measure everything in very minute quantities. So they measure in units of milli equivalents per liter. Okay, that's even much smaller than. So 1 millimolar is 1 milli equivalent per liter. So what is 1 millimolar? 1,000th of a molar. We already know what is molar, right? One molecular weight in 1 liter. So if you divide that weight by 1,000, you will get 1 millimolar. Okay, which is the same as 1 milli equivalent per liter. Okay, so most of the things you deal with when you get your job after you graduate and go on, you need to know this, even if you don't know now. Otherwise, you are going to mess up. Meaning, you will give somebody more dose of whatever you should not do. Okay, so there is a reason for understanding all of this, not just to get you bored and get myself brained out. Okay. Acids, bases, and pH. Next, what is an acid, what is a base, what is a pH? Let's look at the picture on the next page. You see the scale of 0 to 14 with 7 in the middle being neutral pH. Anything that falls between 0 and 7 is considered acidic. Anything that falls between 7 and 14 is considered basic substance. And you can look at the examples they have given. Like you have extremely potent acid in your stomach, but we are safe because of the basic lining of the membrane of the stomach that neutralizes the effect. So your stomach gets disturbed or damaged, then you'll get the burn and ulcers and whatnot. Okay, wine, lemon juice, these are all banana. You can see the acidity level changing. Water, pure water being neutral, and some of the bleach, ammonia and all highly basic, right? So you need to understand the scale, what range is acidic, what range is basic, and also you need to understand what do you mean by an acid and a base. Not only that acid has a pH range 0 to 7 and base has 7 to 14, neutral being 7, but if you look at the definition, what does it say? Acid is a proton donor that releases H+. You see the definition? It's highlighted, guys. Base, what does it say? Base is a proton acceptor. Okay, so for example, some of the acids which we know, like HCl, it's in our stomach too, H2SO4, hydrochloric acid, sulfuric acid, nitric acid, all these when they dissolve in water or in other solution, they split, like sodium chloride split in water, right?
Yes.
So they release hydrogen ions. So by definition, that's what they are saying. Any substance that releases hydrogen ions, because they are positively charged, they also call them protons. Okay. But if you take some of the bases, like KOH, potassium hydroxide, or sodium hydroxide, and so on, they split and release OH minus instead of hydrogen by nature. Okay, these substances. So these substances are considered to be basic, and because they release the negative charge, they have an attraction for the hydrogen. So that's why they call them proton acceptors. You see the definition? Okay. this is, I'm trying to explain the definition there, but basically the pH scale is determined based on the hydrogen ion concentration. So if you have, let's say, a solution where you have KOH and also HCl, okay, so this is going to release some H plus, some amount, and this is going to release OH minus some amount. So there is some of each, okay, in that solution. Okay, so if you have lots of this and less of this, that's going to be highly acidic in the range 0 to 7. If it's the other way around, it's going to be in the range 7 to 14. So in your body pH has to be maintained at 7.35 to 7.45. If it goes towards this, you have acidosis. If it goes higher, you have alkalosis that will upset your metabolism and lead to more consequences. So your body has to be maintained at this pH, close to neutral, but this is the correct pH. Okay? So in order to do that, there are systems, there are compounds in the body that buffer this pH within that range. Okay? So that's why we need to understand what is acid, base, what is the range, and what do you mean by that. And at the end of the page, you have buffers. What are buffers? Buffers are chemical substances that maintain the pH within a range. So you can, in the body it maintains around that range, but you can, in a lab setup, you can create any kind of pH by mixing these two things. You can set a certain pH range for a certain study. And you have something about every chapter as clinical application. If you are upset with me for making you read this, you can read the clinical application, why I'm making you do that. Okay? See, effect of pH on drugs. If you take some drugs with your coffee or lime juice or soda, we don't know. Depending on the drug, it may not work or it may be counterproductive.
Right, like on
So only water, huh?
Like when you have a prescription, sometimes they say take with food, don't take with food.
Right.
Don't take with alcohol.
Yeah, yeah. So you have all precautions for, so don't take a Coke in your medication. It's good to drink with water. Okay. What time do we have? Okay, well, let's stop there. We finish at 4:45, right? So we need to do the energy and the chemical reactions. We'll start from there and continue with the organic compounds. I wanted to finish the energy and the chemical reactions too. It's not very complicated, so we will do that and continue with the organic compounds. Okay, and then we will wrap up the chapter 2 in the next class.